Okay, so let's take a look at solving this system of a linear equation and a quadratic equation by graphing. And so when we solve something like this top equation, which is a quadratic, and it's already almost in vertex form, I'm just going to go ahead and finish it off by getting this minus 3 to the other side and making that plus 3. And now I can tell from looking at that that is a parabola that is shifted 1 unit to the right and 3 units up. So this is scaled by 2, so 1 unit right and 3 units up would be right here. It's opening upward, so that means I have points on it like when I go to the right 1, I'd go up 1. When I go to the right 2, I'd go up 4. 1, 2, 3, 4. And then same thing on the other side. When I go left 1, I'd go up 1, or when I go left 2, I go up 4. 1, 2, 3, 4. And that's a parabola that looks like this. Opens up. Okay. Now the line, if I put it in slope-intercept form, is y equals negative 2x plus 5. So it has a y-intercept at 5. So that's right here, and it's got a slope of negative 2, which means I could either go up 2 and left 1, which looks like right on that point, or I could go down 2 and right 1, which is right there. And when I connect them, I've got it hitting in 2 spots, and it looks like it's hitting on 2 integers. It actually looks like it's hitting on the vertex, which was at 1, 3, and it also looks like it's maybe hitting at negative 1 and 7. Now if I wanted to know for sure if that's where it was hitting, I could go ahead and plug those back in and see if they worked. If I substitute 1 back in, 1 minus 1 is 0 squared is 0. So then if I put the 3 in for the y, that would be 0 equals 0. That works. Plug the negative 1 in. Negative 1 minus 1 is negative 2. Squared is 4. And if you put 7 in here, 7 minus 3 is 4. So that one checks in the first one, and so does the second point. And then you can plug it in the second one and check it as well. Plug 1 in here. Negative 2 times 1 is negative 2 plus 5 is 3. Plug negative 1 in. Negative 2 times negative 1 is 2 plus 5 is 7. And so that second one checks. So number 9 is a perfect system to do substitution on, because anytime you have your quadratic is in this expanded form, and it also doesn't have a middle term, it doesn't have an x squared and an x term, you could just simply solve it for y, and that would be y equals x squared minus 7. And then right up here in this equation, all you need to do is wherever you see y, you can put that x squared minus 7 in its place, and that gives you a pretty simple equation you can solve either with completing the square or quadratic formula. So then just get everything on the same side. That would make x squared plus 6x. If you add the 16 to both sides, that makes plus 9. And this actually already is a perfect square trinomial, so no reason to even have to do completing the square. You can just simply factor it into an x plus 3 squared equals 0. Go ahead and take the square root of both sides. X plus 3 is equal to the square root of 0, which is just 0, and then solve for x by subtracting 3. So x equals negative 3. So since we only have one x value, there's just one point of intersection, and it's at negative 3. And then when you plug negative 3 back in to one of the equations, probably the easiest one is this one right here, and that would be y plus 7 equals 9, and then subtract 7, that makes 2. So your solution, or that point of intersection, is negative 3, 2. Okay, so let's finally look at one that really kind of lends itself right for elimination. And so I'm going to go ahead and take a look at number 14. So number 14, first of all, I see a y here and a y here. So I mean, we've kind of been working with elimination where everything with a variable had to be on the same side. I mean, technically you don't have to do that. But if I were to take, say, this bottom equation and change all the signs and make that negative y and plus 7 and negative x, so that we've got, now opposite coefficients on the y's, and I just were to add now down the columns. If I add the y and the negative y, they cancel out. Then there's plus 7 here, or positive 7. And on this side, when I add, I have x squared. I have the 2x I can add with the negative x, which makes plus x, and then plus 7. And now I can get everything on the same side by subtracting 7. Well, that actually works out okay, because now that cancels out the 7 on that side. That's x squared plus x. And if I want to use the quadratic formula, then I could just go ahead and use the quadratic formula with a being 1, b being 1, and c being 0. And if you remember, that just actually means that because, when you do the minus 4ac, okay, that second part of the discriminant is going to be 0. So that should be an easy one to find the x or x values for, and then plug back in to find the y's. So that would be one that was kind of really tailored towards elimination. But you can see that we would really use substitution quite a bit as well. So hopefully that gives you a little jump start on attacking some of these problems, and I'll see you in class.